here we come to the first example of an example problem that I have. Normally in my lectures, what I do is when we get to this type of a problem where, for example, if we want to further dissect classifying matter, I have a problem listed here, which is identify the following as an element, compound, homogeneous or heterogeneous mixture. There are 6 items listed. How I normally handle this in class is I just let students kind of break out and work together. So either on your own or in partnerships or in groups, people can discuss and come up to kind of a concise and conclusive answer. Obviously, we can't be doing that with pre-recorded lectures, so what I'm going to do instead, first, pause the video, see if you can't answer these questions for yourself. Can you identify whether wine, Cl2, sugar, snow, are these elements, compounds, homogeneous mixtures, or heterogeneous mixtures? As you unpause the video then, I am going to kind of talk through, here's how you would classify potentially each of these pieces of matter. Second part is I am also going to extract this section from the lecture and post it as a separate video. So that way, if in the future you would like to come back and refer to this example problem, you can without having to scrub through the entire lecture to find it. And this is going to be true of every example problem that is going to be present in each of my lectures. I will answer the question in the context of the lecture, but I'm also going to extract it into a separate video, so that way if you want to come back, it's going to be much easier to find. All right, so here's the moment. Pause the video if you're watching, break this down for yourself, is it decompress? Is that the word I'm looking for? Process the information that I have given you so far. See if you can't answer this question on your own before we come back together. All right, assuming that you just paused and unpaused, we are now going to go forward and answer, I will answer the questions, I will define each of these, I will classify these forms of matter as elements, compounds, homogeneous mixtures, heterogeneous mixtures. All right, so the first example here, wine. We're just gonna go through each of these one by one. First is wine. All right, so if you think of a glass of wine, you think of a beverage that you drink. Something akin, again, to a glass of milk, a glass of water, whatever. You do want, and you would also expect that this piece of wine, this substance of wine, is going to be some type of even mixture. Even because you would expect the components to not chunk up. I mean, if your wine is chunky, it's probably gone bad. You would also assume that wine is going to end up being a mixture. And the reason why is, if you think about, again, the process of making wine, if you are aware of what this process is, you end up smooshing grapes, right? That's kind of the classic image, is a bucket of grapes, people stomp all over them. The foot fungus ends up allowing for the fermentation process of the grape juices, which eventually over time creates wine. So we have water, we have grape juice, we have alcohol present. There are multiple facets, multiple pieces that comprise wine, hence it being a mixture. So if we're looking at something that is an even mixture, by definition, this is going to be a homogeneous mixture. Right, so when defining or classifying matter in the world around you, you're gonna have to use either context or previous experience, or kind of look up to see, is there an ingredient list for wine? Is it made up of 2 or more substances? Yes or no? That's gonna help to answer that first question. Is it a mixture or not? And then the second caveat is it going to be even throughout or not? Right, so wine, we would expect to be a homogeneous mixture. Cl2. Cl2, first of all, we can see is present as a chemical formula. Well, you can't write one single concise chemical formula for any type of mixture. And the reason why is that a mixture, again, is 2 or more pure substances. You would have to write 2 or more chemical formulas if the substance was a mixture. So right away we know that Cl2 is not a mixture, it is going to be some type of pure substance. Our follow-up question is, how many element types are present? Now Cl2, there are 2 chlorines, so there are 2 atoms present inside the molecule, but each of those atoms, each atom is the same element type. Each of the atoms is chlorine. And so because we have a chemical formula, so we're looking at a pure substance, and each of the atoms inside is made up of the same element, we can define Cl2, we can classify this piece of matter as an element. All right, next up, we have air. Air in the world around us, just neutral, natural air. Well, air, we know from past experience, I'm sure you've learned this at some point, is comprised of like 70% nitrogen, it's like 20% oxygen, it's got a bunch of CO2, it's got argon. These are the top 4 like components of air. And because now here we can see, kind of in contrast to the Cl2 example from before, we have multiple chemical formulas present inside of air. And because we have multiple chemicals present, we would assume that this is going to be some type of mixture. The question is, what type of mixture is it? Well, to answer this, all we have to do is think about our experience with air as we just observe it in the world around us. As we're walking around, we don't have to chase like pockets of oxygen throughout the nitrogen to stay alive, right? We can just sit where we are, and the air is kind of evenly dispersed in the world around us. So because the air is evenly dispersed, thank God it is, we are working with a homogeneous mixture. Like, could you imagine if air was heterogeneous? And I mean, okay, if you zoom out far enough, if you like consider the total atmosphere going out into space, yes, there are distinct layers that form there, but we're not talking about those distinct layers. We're not talking about the atmosphere. We're talking about ambient air around us. All right, next we have stew, right? Just a chunky soup that you can eat. Well, I just said the word chunky. And if there is anything chunky about the substance that you are observing, about the piece of matter you're observing, chances are it's a heterogeneous mixture. Right? It's not chunky in terms of like texture necessarily, it's chunky in the sense that you have like beef broth and like visible chunks of like peas, potatoes, tomatoes, beef. Like, because there are all of these different pieces that have distinct and easily separatable pockets, we are clearly looking at a heterogeneous mixture of multiple things just kind of being physically mixed together. All right, sugar. Honestly, sugar and snow lead to like the best discussions in class, and the reason why is that you can possibly argue multiple answers for these. So sugar first. If we think of just classic sugar, like sugar that you pour into your coffee, sugar that you like eat inside of like cookies or whatever, classic sugar is glucose, which is C6H12O6. And that's it. We have one distinct chemical formula, and this one distinct chemical formula is made up of 3 different element types. And so the most straightforward definition for how we would classify sugar as matter would be a compound. Right, that's the path of least resistance. Occam's razor, easiest answer is probably going to be the answer. We're just looking at a compound here. The reason why sugar has a second answer though, a second option, is not all sugar is glucose. We also have sucrose, there's fructose, like for instance, high fructose corn syrup, and there are sugars that are sold commercially that can just be generically referred to as sugar that are a combination of all of these lesser, or like, I shouldn't say lesser, right, some of the parts. It's a combination of glucose, fructose, all of the different oses that make up sugars. And if we're looking at a combination of these sugars, we are looking at a mixture of some sort. How closely, like, how do I say, all depending on how small the grain of the sugar is and how evenly mixed it is, you could be working with a homogeneous mixture or a heterogeneous mixture, but it would be a mixture nonetheless. All right, so if you're that really, if you're that type of like pedantic person who's like, well, technically, chances are your answer is going to end up being the mixture answer, because a lot of the time, again, sugars, especially if they're sold in syrups like Caro syrup, are going to have multiple sugars present. All right, and similarly, snow is going to have multiple answers. Now, the most generic answer, again, the most straightforward answer, and this is the answer that most students give, well, snow is just frozen water, and frozen water is made of H2O. Just like the sugar example, we have one chemical formula comprised of two different elements, meaning that we would define snow as a compound. But again, if you're that type of like pedantic person who like, you know, in the middle of this conversation, I imagine someone who looks very like Urkel-ish, just like knowingly pushing up their glasses up the bridge of their nose, and they're like, well, actually, if you think about the construction of snow, snow is formed specifically in the upper atmosphere because there is some type of piece of sand, hair, dirt that has been kicked up into the upper atmosphere that allows water to freeze onto. So at the heart of every piece of snow, there is a little like speck of dust, a speck of skin, a speck of something that allowed water to aggregate to it. So if we're thinking of that, if we're thinking of there being this like little seed and the snowflake building up on top of that, we're going to be looking at a heterogeneous mixture. Right, because we could break off all of these ice crystals from this little speck, isolate the speck, it'd be pretty easy to separate that. All right, so I like this example. Kind of starts off easy and straightforward, then it kind of makes you think the further and further you go, because all depending on how you defined the type of matter you are working with, you could end up with different classifications. So it's going to be really important to, when you are communicating either with your peers, with me, like exactly what type of matter are you working with? Is it just a generic kind of image of something like wine or air? Or are you going to end up being more technical? What type of sugar? What type of snow? Real or hypothetical are we working with here?